Hello students, welcome to this video lecture, and here we are going to discuss few CBSE pattern questions of the chapter Introduction to Euclids Geometry. As we remember, Euclids Geometry is a very theoretical chapter. We studied definitions, axioms and postulates. In that we have to remember all of them. Mostly we will get theoretical questions, small questions here, but still we have to study this chapter because this is a basic or foundation for mathematics and many other theorems in other exercises. So, first question is of 1 mark, and there are 3 questions, and it is asked which of the following statements are true. So, let us see one by one each of these statements. First statement is a line segment has no definite length. Is this true? No, this is not true, because a line segment has a definite length. A line does not have a definite length, a ray does not have a definite length, but a line segment has a definite length, because a line segment has a starting point and has an end point. In case of a ray, it does not have an end point, it has only a starting point. In case of a line, it does not have a starting point, it does not have an end point. So, ray and line does not have definite length, but line segment have definite length. So, we say that this statement is false. A ray has no end point, as we just discussed. A ray has one end point, which is the starting point, another is not an end point. So, this is also a false, it has one end point. A line has a definite length? No, a line does not have a definite length, because it extends to infinity both the sides. So, this which I have drawn here is a line segment. So, this is a line segment, this another is a ray, and this third is a line. So, line and ray does not have a definite length, but line segment is having a definite length. So, this is also false. So, we should have proper understanding of line segment, ray and line. Line segment has a starting and an end point, and it has a definite length. A ray has a starting point and it extends to infinity on the other side, and it does not have a definite length. A line does not have a starting and an end point, it extends to infinity both the sides, and it does not have a definite length. So, this is a 1 mark question. We have the proper understanding of all the 3 things which we have studied. Second question, which is of 1 mark, says a line AB is the same as line BA. So, we will say yes, the line AB is same as line BA, because line AB will also extend both the sides and line BA will also extend both the sides. So, this is a true. A ray AB is the same as ray BA? No. A ray AB is starting from A and ending indefinitely, and ray BA will start from B and extend indefinitely along A. So, they have 2 different directions. AB is directed from A to B, BA is directed from B to A. So, this is a false statement. 2 distinct points always determine a unique line. Yes, if we take 2 distinct points, this we studied in this. If we take 2 distinct points, there is only one unique line which passes through both of these points. So, we will say that yes, this statement is of course true. So, after this, let us come to the next question. Another question says, which is also of 1 mark, again true and false. So, what are the statements here? 3 lines are concurrent if they have a common point. Yes, this is the definition of concurrency, that if the lines have a common point, then they are said to be concurrent. These 3 are concurrent lines, they have a common point. If we take it like this and this, these are not concurrent, they do not have a common point. So, yes, this statement is true. 2 distinct lines cannot have more than 1 point in common. So, this is same as we studied in previous question, that if we take 2 distinct lines, then there can be only 1 point which is common to them, not more than 1 point. So, this is also true, it has not more than 1 point in common. So, 2 distinct lines cannot have more than 1 point in common. Or we say from one point we can draw infinitely many lines, okay, but no two distinct lines have more than one point in common. Third, two intersecting lines cannot be both parallel to the same line. This is also correct. We studied this as the last postulate, that if we are taking two intersecting lines, it cannot be parallel to the same line. If this is parallel to this line will never be parallel to this. So, two intersecting lines can never be parallel to the same line. So, this particular statement is also true here. So, all of these statements are true. Let us come to the fourth question, which is of 2 marks now. Now, all the questions are of 2 marks. These are single correct multiple option type questions. Which of the following needs a proof? So, an axiom needs a proof, a definition needs a proof, a postulate needs a proof, or a theorem needs a proof. So, we all know that a theorem needs a proof. Postulate, definition and axiom do not need any proof. They are accepted as they are given. So, for this we have to understand that only theorem needs a proof, and we give proof in order to prove the statement of the theorem. Euclid stated that all right angles are equal to each other, all 90-degree angles are equal to each other in the form of an axiom, a definition, a postulate or a proof. So, what did we study? This we studied in axiom. We studied 3 things in this chapter: definition, axiom, postulate, and this we studied in axiom, that two right angles are always equal to one another. So, we will say for this the option A is correct, students. Next, 6th question. The side faces of a pyramid are, this is quite easy. You have seen pyramid, it is a shape which can be drawn like this, and let us join this. This is a sort of pyramid. This has 4 faces. You have studied also pyramids of Egypt. So, this has 4 faces. This is a base and it has 3 other faces. So, total 4 faces. So, what are these faces? Are they squares, triangles, trapeziums or polygons? So, these faces are all triangles. This is a triangle, this is a triangle, this is a triangle, and the back side will also be a triangle. So, we will say the side faces of a pyramid are triangles. Okay, students. Now, let us come to the 7th question. Which of the following is a true statement? So, let us see each of one of the following. Only a unique line can be drawn to pass through a given point. This is not true. If there is a given point, there cannot be a unique line which can pass through. There can be infinite lines which can pass through it. So, only a unique line can be drawn to pass through a given point is a wrong statement. Infinitely many lines can be drawn to pass through 2 given points. This is also wrong. If there are 2 given points, you cannot pass through them infinite lines. There can only be one line which can pass through them. So, a unique line can pass through 2 given points which are distinct points. So, this is also a wrong statement. If 2 circles are equal, then their radii are equal. Yes, this is correct. If 2 circles with equal radii are there, then we say that these 2 circles are equal. The only thing that makes the circles equal are their radii. So, we will say this is the correct statement. A line has a definite length. Again, we studied a line does not have a definite length, it has indefinite length, it extends to infinity both the sides. So, the correct answer is C here. Let us come to the question number 8, which is of 2 marks again. This is saying a point C is called the midpoint of a line segment AB if, so there is a line segment AB and there is a midpoint C. So, under what condition we can say that C is the midpoint, that is this length is equal to this length. C is an interior point of AB. Yes, this is correct, but it is not enough. If we take C here, which is also an interior point, but that is not enough to define it to be the midpoint. Second says AC is equal to CB. So, if we take a point on this perpendicular bisector somewhere here, AC is equal to CB here also, but this is not the midpoint of this line segment. So, this is also not fully correct. Okay, this is not the sufficient condition, this is the necessary condition. A is also the necessary condition. Third says C is an interior point of AB such that AC is equal to CB. So, C is combination of both of them. So, if we say that AC is equal to CB and also C lies in between AB on the same line, then we say that it is the midpoint of AB. So, this is correct. These both were the necessary condition, but when both of them will be presented together, this becomes the sufficient condition. So, this is the sufficient condition. AC plus CB equal to AB is not also enough. We take C here, A here, B here, AC plus CB is equal to AB, but of course, C is not the midpoint. So, for a point to be the midpoint of a line segment, that should be an interior point and the distance from one end should be equal to the distance from another end. Let us see the next question, which will be also a 9th question of 2 marks. The number of planes passing through 3 non-collinear points is. So, if we are taking 3 non-collinear points, let us take here, this is one point, this is another point. Non-collinear means they are not lying on the same line. We can't take points like this, this is in the same line. We have to take points non-collinear like this. You cannot make a line out of these 3 points. Okay? If we take here, you can make a line. So, these are non-collinear points. Now, how many planes can pass through them? Only one plane can pass, that is this blackboard itself, no other plane. If you take a plane like this, it passes through these two, but not this. If you take a plane like this, it passes through these two, but not this. So, only one plane, which is this blackboard, is passing through these 3 non-collinear points. So, we will say the answer is 1, students. So, let us come to the last question of 2 marks now. The last question says, find the measure of an angle if 5 times its complement is 12 degree less than twice its supplement. So, we should know what is complement and supplement. If x is an angle, its complement is 90 degree minus x, and if x is an angle, its supplement is 180 degree minus x. So, let us solve this. Find the measure of an angle. Let us suppose that angle is x. If 5 times its complement, that is 5 times of 90 degree minus x, complement of x is 90 degree minus x, is 12 degree less, that is 12 degree minus twice its supplement, twice of 180 degree minus x. 180 degree minus x is the supplement, multiply it with 2, this will become twice, and subtract 12 degree. So, we can say this is 450 degree minus 5x is equal to 360 degree minus 2x minus 12 degree. So, this will be 450 degree minus 360 degree plus 12 degree is equal to 5x minus 2x. 450 minus 360 is 90, 90 plus 12 is 102 degree is equal to 3x on the right hand side. So, x comes out to be 102 degree by 3. So, 3, 3, 9, 3, 4, 12, 34 degree. So, the angle is 34 degree. If we take 34 degree angle, then 5 times of its complement is equal to 12 degree less than twice of its supplement. So, this was the last question. With this, we complete the CBSE pattern exercise of this chapter, Introduction to Euclids Geometry. Students, keep practicing. Okay, students, thank you.